So, welcome to lecture 25. It is a continuation of this organic field crop management of the cereal crops. As we are discussing the rice crop, we discussed the previous lecture. So, especially the planting technique for the rice. So, which planting method is to be followed for organic, especially go for the young seedling as a wider spacing and as a one seedling or two seedling per hill. So, that can give a better growth and also for the better yield. So, we at the same time saving huge amount of the seed requirement and the water requirement. So, now we will discuss about this nutrient management, how to calculate if you go for the organic sources. So, as we discussed for potato crop, similarly for rice crop, based on the nutrient composition of different sources, you can calculate the requirement of the different organic sources of fertilizer. Likewise, as I have seen the potato crop we discussed, this is a conventional vermicompost or the microbial enriched vermicompost, rock enriched vermicompost FIM. The simple FIM, they contains only nitrogen 0.5%, total phosphorus 0.2% and potash 0.5%. If you go for the conventional vermicompost, as this is due to release of earthworms, that contains around 1.3 to 1.5% nitrogen and 0.81% phosphorus, 1 to 1.1% K2O. So, by changing your composting process from the conventional farm-made manure to conventional vermicompost by using the earthworm as we have discussed earlier. So, this increases the quality of the compost by increasing nitrogen, phosphorus and potash content, because the earthworm secretions and the process of mineralizations that helps in mineralizations, that helps having the higher nutrient content. So, if you go on improving the conventional vermicompost with the microbial enrichment by using different microbes, either the nitrogen fixing, phosphate solubilizing or the potash releasing microbes, as we have discussed also. So, that also helps increasing the nitrogen and the phosphorus and potash content. So, in addition to that, if you go for the enrichment with specific elements, either for the nitrogen or for the phosphorus or the potash, by having the rock enriched vermicompost, you can have improvement in the NPK content. And using those different sources, we can calculate the dose of rice. Like potato, we calculated the dose of the sources of manures or the fertilizer based on the potash contents. In case of potato, here as the requirement of chemical fertilizer 100 kg nitrogen, 50 kg P2O5, 60 kg K2O per hectare for the rice crop, the cereal crops. So, nitrogen requirement is higher as compared to phosphorus and potash. So, we calculate the doses of these organic sources based on the N requirement, that is 100 kg per hectare. So, likewise as you did for the potato crop. So, for the farm-made manure containing only 0.5% nitrogen. So, used 20 tons of farm-made manure to meet the nutrient demand of the crops. But if you use conventional vermicompost or the rock enriched vermicompost, they have the similar requirement, either 7 tons. This is because of the conventional vermicompost or the rock enriched vermicompost, there is no change in N content. The nitrogen content remains same. So, as we are trying to meet the N demand of the crop, so that the yield level should be maintained. We do not want to sacrifice the yield in case of organic farming. So, that to meet the nutrient, the nitrogen demand. So, the requirement of conventional vermicompost or enriched vermicompost remain same. But if you go for the microbial enriched, where there is a higher nitrogen content as compared to conventional or the rock enriched vermicompost, with microbial enrichment, the dose of the vermicompost is reduced to 4 tons per hectare. So, so the application of this can be applied basally, that means at the time of the final land preparation just before planting, and this can be incorporated, either you can use conventional vermicompost or microbial enriched or the rock enriched vermicompost. This compost should be well incorporated in the soil at the time of the final land preparations, that means when you go for the labeling and then you can go for the planting operation. So, if you come to the pest and disease management in case of the rice. So, as general precautions, as you have discussed for the organic farming, you should follow, you have to have a resistant varieties, the variety which is free from most of the pests and diseases. So, select the resistant as well as well adapted varieties for specific areas. Then select the clean and disease free seeds, because many diseases are the seed borne diseases. So, while selecting the seeds should be free from diseases. Proper agronomical practices like optimum planting time is very important in case of the organic farming, because if you make a delay planting or early planting, first of all the yield gets reduced, because if in case of rice crop, suppose the planting time in followed for the months the kharif rice around July 15 or 25 30 the best. July 15 to July 30 you can say best time, especially for eastern India you go for the planting. If you go for the early planting, what will happen? Because there is a optimum temperature for the flowering period also. So, as you said temperature may be around 25 degrees Celsius the grain filling. So, that encourages the better grain filling. So, early planting the crop may not get that favorable temperature for grain filling, the yield will be reduced, and late planting also that the temperature become very low, then also the grain filling becomes poor, that causes yield reduction. And moreover, the changing planting time and the temperature and the humidity, that becomes congenial or favorable for many insect pest and disease. The crop also suffered from the pest and disease attack by shifting the planting time. If you go for the early or the late planting, so the crop is also infested by several pests and diseases, that causes also yield reduction. So, that is the planting time is very important for the farming practice, that should be followed very strictly to have a better yield and to have a pest and disease free crops by having the optimum planting time. Then of course, the good water management that can you can keep there is some insect and disease attack, the field should be well drained out, the water should be drained out from the field to protect the crop from the spread of the pests and diseases. Then you go for the field preparations. At the field preparations, what precaution you can take for the pest and disease management? Apply farm made manure pre-colonized with the Trichoderma harginium or Pseudomonas fluorescens. So, this microbes can be pre-colonized with a farm made manure that can be released in the field, so that they can protect the crop from many insect pests and diseases. For the pre-colonization of farm made manure, either the Trichoderma harginium or the Pseudomonas fluorescens is to be added at monthly interval in the FOM pits around at the rate of 100 gram per pit, and this pit should be covered with the either rice straw or the sugarcane leaves and should be watered regularly, so that to maintain a proper moisture for the growth of the microbes, beneficial microbes as the Trichoderma harginium or the Pseudomonas fluorescens. In green manuring, when you go for the incorporation of green manures in the field before at the time of land preparations before the transplanting of the rice crops, at that times, so Trichoderma harginium or the Pseudomonas fluorescens can be also applied in the field at the rate of 5 gram per liter. So, that can be incorporated in the field, also that can serve as that can protect the crop from many insect pests and diseases. Nursery sowing time also, when you go for the nursery seeding, because when you go for rice crop we can go have the different type of nursery. So, in the nursery field the seed can be treated with salted water followed by Trichoderma harginium and the Pseudomonas fluorescens at 5 gram each per kg of seeds. Because when you go for the nursery seeding, because we soak the seeds in water for around 12-20 hours, they can be soaked, and then it is packed in a gunny bag as perforated bags for maintaining the optimum temperature for germinations of the seeds. So, during soaking there is swelling of the seeds, use the salted water and as this microbial inoculum as a Trichoderma harginium and Pseudomonas fluorescens, that can, so that the seed borne disease can be avoided. Use pheromone trap also in the nursery bed to control the stem borers, and that can be one pheromone trap can be used per 100 meter square of nursery area. And also you can release the Trichoderma japonicum or Trichoderma silinoes around the 150,000 parasitoids per hectares to control any insect pest and disease in the nursery bed. So, while going for transplanting, so before transplanting, nursery bed can be treated with the a drenching of Pseudomonas fluorescens at 1 gram per meter square of nursery. So, that can be treated 1 day before transplanting for the seedling treatment. So, that seedling the main field should not be infested with the pest and disease. So, these are some of the measures that can be taken care without waiting for the appearance of the disease or the attack of the insect pest and disease. So, or the seedling can be dipped, or that is the root of the seedlings can be dipped in the suspension of Pseudomonas fluorescens, that is around 5 gram per liter. So, this either the applying the Pseudomonas fluorescens in the nursery beds before uprooting of the nursery, or after uprooting the seedlings can be dipped in the suspension of Pseudomonas fluorescens, so that we can control many of the pest and diseases in the main field. After transplanting, so till maturity, when the crop in the main field, we can use the pheromone trap, and the number of traps around 20 traps per 1 hectare of main field, and 1 traps with the area of around 20 meter into 25 meter area, and 5 milligram pheromones per trap. And this pheromones that can be also that can be used within a week before week of transplanting for stem borer, and replace this pheromones every 30 days. So, this pheromone trap, as we discussed earlier also, this can be used in the main field for controlling especially the stem borers. Avoid water stagnation, and at the time of the attack of insect and pest diseases, the field should be drained out. So, if there is standing water, the field can be drained out. So, the spread of the disease or the insect pest can be controlled. So, in that case, as we are discussing the SRI system, that is very good, because it is less infested by pest and disease, because you do not put the standing water, only saturation is maintained, field capacity and saturations, no standing water. In that case, there is a less disease and pest in case of SRI as compared to the conventional transplanting, where more than 5 centimeter standing water is maintained. Of course, we can spray 10% cow urine mixed with neem leaves, or the spray of cow urine should be started at 25 days after transplanting, and subsequently 3 to 4 sprays at 15 days interval. And we can spray vermiwash, 5% vermiwash or vermicompost tea treated with Trichoderma harginum and Pseudomonas fluorescens. So, compost tea, that is also a very good aspect to have a control on pest and disease. What do you do? Also, this supplies many nutrients. So, the compost, around 1 part of compost mixed with a 1 kg of compost with 10 liter of water, and they are stirred by the mixie, like a mixie with a high speed stirring. And after stirring then when the compost is fully mixed with the water, then we make filtration, and this the liquid extracted, the filtered liquid, that is known as compost tea. And the tea can be sprayed on the canopy, and you can make some dilution also with water, maybe 1:5 times, and that can be sprayed over the crop canopy. And with that we can control many pests and diseases, and of course, it supplies most of the nutrients of the foliar spray for the growth and development of the crop. And spray mixed formulation of compatible strains of Pseudomonas fluorescens and Trichoderma harginum, that is 5 gram each per liter of water at panicillin sessions for sheath blight, sheath rot, neck blast. One spray to be given at weekly interval. So, by using the Pseudomonas fluorescens or the Trichoderma harginums, the strains are mixed together, and they are 5 grams per liter of water, and they can be sprayed regularly to control blight disease, rot disease, and the blast disease of the rice. And coming to wheat crop, because wheat this is a cool season crop, and the average temperature during the sowing is around 10 degrees Celsius to 15 degrees Celsius, and ripening are the grain filling periods, as you say, that is at 21 degree Celsius to 26 degree Celsius. Wheat grows better in those areas where rainfall occurs in usually winter seasons, and irrigation serves as the best if rainfall is below 50 centimeters, and you can provide the irrigation water. And soil which grows best in well drained fertile loam of either alluvial soils type or the black soil type. The optimum pH range is 6 to 7. So, unlike the rice, as in rice we go for the purling, but wheat does not require purling, can go for the normal tillage operations, the primary tillage followed by secondary tillage to have a loose soil for sowing of seeds. So, before sowing, usually when you go for the wheats, we go for the pre-sowing irrigations. If the soil is hard, there is less moisture, we go for the pre-sowing irrigation, irrigation, so that the soil can be brought to optimum moisture content for proper tillage. Because if you till the soil at the high moisture content, there will be clod formations, that is not good for the wheat sowing, and with the low moisture content you get the more draft for the tillage operations. So, that is the optimum moisture content that should till, so that you can have a loose soils, not very because high, because if you go for the high moisture content, there is a higher clod formation, which is not good for the wheat germination, because it can affect the germination or the establishment of the wheat seedling. So, proper soil moisture content, the tillage operation should be performed. Then seeds sown row spacing 20 centimeter. So, after land preparations, usually the depending upon the soil moisture, if it is very dry, we can go for the pre-sowing irrigations and then go for the sowing of the wheats, or after sowing we can go for irrigations, because post sowing irrigations causes the less emergence of the wheat seedling as compared to pre-sowing irrigations. Pre-sowing irrigation is preferred than the post sowing, because post sowing irrigations, there will be drifting of the seeds from one place to other place, and there may be accumulation of water in the field if the field is not well labeled, that causes the loss of seedlings or the death of the seedlings, that the seedlings may not emerge because of the water accumulation. So, that is why we go for the pre-sowing irrigation, then go for the sowing, that have a uniform germination and the stand establishment. And so, in the sowing time you can have a source of mustard crops on the sides of the field, so that it can serve as a trap crop for some insect pests. They are attracted towards the mustards. So, main crop can be free from many insect pests and diseases. Nutrient management. So, like rice, wheat also that requires nitrogen in the greater amount as compared to phosphorus and potash. The dose of chemical per wheat is higher as compared to nitrogen, 120 kg nitrogen, 50 kg P2O5, 60 kg K2O per hectare. So, in fact, if you say the especially for the rice, as you see, as you discussed also, rice is grown under transplanted conditions and the flooded, because you are going anaerobic conditions. In that case, as you are maintaining water, in that case many of the micronutrients as saturated conditions or the standing water, as you see, many of the micronutrients are available in the rice field. So, the efficiency of the applied external source of nitrogen is very low in case of rice, but this does not happen in the aerobic crops like the wheat crops, where we require we need the fertilizer. So, without nutrient applications, the yield will be very low. So, the nutrient dose is 120 kg nitrogen, 50 kg P2O5, 60 kg K2O per hectare, and based on that similar calculation as we discussed for the potato crop and rice crop also, based on the N contents the FIM contains 0.5% nitrogen, and to meet 120 kg of nitrogen we require 24 tons of FIM per hectare. But if you use the conventional vermicompost or the rock enriched vermicompost, the requirement is 8 tons per hectare, but microbial enriched vermicompost 5 tons per hectare. So, to reduce the size of the compost material or the organic sources, we need to go for enrichment. If you can go for enrichment, we can apply less amount, which is very feasible. We can get the amount less amount, at the same time we can meet the requirement of the crops to have a better growth and yield of the crops. So, so that is why when you go for the organic farming, the enriched vermicompost, either the microbial enriched or any specific nutrients rock enriched to meet the phosphorus, and the mica enriched compost or the dolomite enriched compost to have a calcium, magnesium, mica for the potash, and the microbial enriched vermos like nitrogen fixing organisms or the phosphate solubilizing or potash releasing bacteria that can be incorporated in composition process to have a better availability of mineralization of nitrogen in the main field itself. So, that is why based on your enrichment we can minimize the requirement of the organic resources by from 24 ton to 5 tons. So, there is a huge reduction in the requirement of organic resources by doing vermicomposting and enriching with microbes and also other rock minerals. See the pest and disease of weeds, usually the aphids, you can control biological control agents such as lady beetles and parasitic wasps and the fly, surface fly maggots, fungal which are often abundant in small grains. So, you can have the biological control agents. Also, you can use the trichogram species that can be released in the field, so that they can control many pests and disease. In addition to this, we can go the regular spray of the, as we discussed the earlier, the pest and disease control, this cow dung, urine mix, and also the cow dung, urine, jaggery, pulse powder, that mix, and that formulation can be sprayed regularly at least within 7 to 10 days interval, so that you can keep the crop free from many insecticide or the insect pest and diseases. And armyworm also, that is as you see the armyworm, that is also very common in case of the wheat crops. To control this armyworm, we can go for the biological insecticide, the biopesticide, that is pyrethrum. As you discussed pyrethrum, how to prepare pyrethrums, we have discussed earlier class. So, using pyrethrum in 10 days interval and 20 gram of pyrethrum powders in 10 liter of water, then 2 gram per liter of water. In case of the sprayer 10 liter of water, 20 gram pyrethrum can be used, and that can be sprayed to regularly 10 days interval to control this armyworm. And loose spot, as you say, this for the viral disease or the leaf rust, sorry, fungal disease. So, the certified seeds in organic farming, as discussed, either the loose spots or the leaf rust. So, as causes due to the fungal disease, fungus, certified seed fields are inspected for loose spots, and strict standards are enforced to collect the seeds that is free from any pest and disease infestations. Seeds from field with loose spots should be rejected, should not be used in case of organic farming. So, using certified seeds is a highly effective way to avoid loose spot. Similarly, leaf rust, organic producer must select variety with a good resistance to leaf rust and select varieties that have a combination of powder mildew and leaf rust resistance. So, because the seed the source, so many pathogens, many diseases in the field appears to the seeds. So, while collecting seeds should be collected from a trusted source, and this should be free from the pest and disease infestation. Those seeds can be used. So, you can minimize many pest and disease infestation in the field. In addition, you have to provide, you have to maintain, in organic farming itself is a preventive measure I have discussed. By doing so organics, using the organic manures in the field, because of the soil environment changes, release of carbon dioxide in the soil, that causes the death of the many pathogenic bacteria, and because of the as you are applying the organics, that increases population of many beneficial microorganisms, and there is a food materials for the pathogens also limited, that way also they are also the population is reduced. And applying this either the botanical pesticides or the doing organics, and as you are the as itself organic farming, the slow release of nutrients. So, that as discussed the stress. So, there is a phytohormones secreted in the leaf canopy leaf. So, in that way also there is less infested by the pest and disease. So, doing organics as a preventive, and also as we discussed earlier classes, the formulations of the cow dung, cow urines, and the neem leaves or the garlic, chili extract, the formulation as we have discussed, those formulations can be sprayed because those are not inexpensive. So, they are available with the farming community. Having a cows is an integral part of organic farming. So, having cattle, so having cow dung and preparing the cow dung based products using the neem leaf or the green chili, garlic extracts. So, this formulation can be sprayed regular intervals at 10 days or 15 within 2 weeks intervals. So, that as a preventive measures to avoid the infestation of any pests and diseases. So, this if you see, by doing so, by doing the organic farming, we are trying to meet the maintain the yield level, because especially as we discussed cereal crops, the challenge to have the same yield levels using the chemical farming. We have to add the huge amount of organic fertilizers, organic manures to have the same yield levels as of chemical farming. But the beginning I can advise at the beginner to avoid the yield loss, we can go for the because especially the locations like tropical countries and subtropical countries, where the rate of mineralization is very fast. In that case, so to meet the requirement of the crops, we need to apply the chemical fertilizers and the organic as a combinations, the beginning of the organic farming. Later, when the soil fertility gets improved with the continuous addition of the organic manures, we can slowly reduce the chemical fertilizers and fully convert to the organic farming. So, there are some research information on the quality of the products of the rice and wheat using the organic production technology. So, there is a G. Su et al. 2007, they have reported there is no difference in amylose and protein contents between organically grown and ordinarily grown rice. So, they are almost same. The other thing that however, the superoxide dismutase, that's the enzyme, that activity of methanol extract from organically grown rice were higher than those of the conventional rice. So, there is a superoxide dismutase, that is a enzyme which fight against the cancer disease, like cancer disease as a antioxidants. So, those are higher in case of the organically produced rice as compared to conventional rice. And second report from Saha et al. 2007, they have mentioned that organic nutrient source can perform comparatively as well as chemical and physiochemical properties, cooking quality of rice, if not better in some parameters than inorganic fertilization. So, they say, so there is not much difference in case of the either chemical properties, physiochemical properties or cooking quality of rice, they are same as of the conventional farming. And there is a Madrid et al. 2007, they have reported high wheat quality in organic farming is achievable by lower inputs, thereby safeguarding the natural resources. They say with the organic resources, the quality of wheat is better as compared to the chemical farming, chemical fertilizer. So, as you see the cereal crops production is concerned, especially for the tropical and subtropical countries. So, beginning to protect the yield, to have a same yield at the beginning, we can go for the integrations of the organic and chemicals, but we should avoid, we must not use any type of synthetic pesticides, that should be banned. Nothing in organic farming, we should not use any type of chemical pesticides. But as for the nutrient is concerned, to maintain the yield levels at the beginning, being the crop specific, for especially cereal crops, we can go for the integrated nutrient at the beginning, but later on we can minimize the use of the chemical fertilizer. Slowly you can convert to full use of organic fertilizer, so that we can maintain the yield level. We should not sacrifice the yield levels, but we should not use any synthetic pesticides in case of the organic farming or organic productions, because having the synthetic pesticides, we can deteriorating the quality of the produce. We want to have better quality and the healthy produce. At the same time, the production should be maintained. So, go for the organics as nutrient managements, go for the organics, and as for the formulation we have given. So, use those organic formulations regularly, maybe 10 days intervals, so that the crop should be protected from many pests and diseases, and you can maintain the yield levels. At the same time, you can have a better quality of the produce, and at the same time can have a better environment to live in. With this, we conclude this lecture. Thank you very much.